Thank you so much for joining this session, which is titled Connecting Securely to Your Kubernetes Clusters. My name is Cesar Saavedra, and I'm a Senior Technical Marketing Manager here at GitLab. If you have any questions after the session, or if you would like to get in touch with me afterwards, please feel free to reach out to me via these social media handles. So GitLab is the AI-powered DevSecOps platform. GitLab includes capabilities for every phase of the DevSecOps lifecycle, from planning to testing to deploying and monitoring, and all in a single application with a single data model and a single user interface. We also provide AI-assisted capabilities, such as code suggestions, explain this vulnerability, summarize issue and merge request comments, explain this code, and value stream forecasting, among others. These AI-assisted capabilities span across the entire DevSecOps lifecycle to help streamline your processes, increase productivity, and speed your cycle times. Some of the benefits you get by using GitLab are improved developer experience, higher performing teams, secure software supply chain, and support for hybrid and multi-cloud environments. GitLab supports two approaches for GitOps. One of them is the push-based approach, which consists of pushing infrastructure updates in Git to an environment, like production, via a CI/CD pipeline, which you can manually configure. This approach supports Kubernetes and non-Kubernetes infrastructure targets and components, as well as many infrastructure as code tools, such as AWS CloudFormation, ECS and EC2, Google Cloud Deployment Manager, Azure Deployment Manager, among others. And we have a tight integration with Terraform, which includes storing and managing your Terraform state file in GitLab, storing and managing your Terraform modules in GitLab, and a Terraform widget in merge requests that allows you to quickly access the results of running a Terraform plan in your pipelines. In addition, specific to Kubernetes, we have the GitLab CI/CD workflow for Kubernetes, which leverages the GitLab agent for Kubernetes and allows you to push infrastructure updates via a CI/CD pipeline. With this approach, organizations can reap the benefits of GitOps by including their legacy infrastructure into their GitOps flows, or reap the benefits of GitOps as they migrate their legacy infrastructure to Kubernetes. The other approach is what we call pool-based GitOps, which leverages the GitLab agent for Kubernetes also. This approach is for Kubernetes infrastructure targets, and it consists of an agent that gets deployed to the Kubernetes cluster and pulls infrastructure updates from Git to the cluster. With this approach, organizations can start reaping the benefits of GitOps for their Kubernetes targets from the get-go. In addition, we are integrating FluxCD, a mature open source GitOps solution, into GitLab. The combination of GitLab and Flux supports a variety of options for configurations and topologies for the automation and management of your infrastructure updates. Here's a high-level architecture of the GitLab agent for Kubernetes. It has an in-cluster agent, named Agent K in this picture, that securely communicates with GitLab via a server component named KAS or KAS. As infrastructure updates take place on Git, the agent immediately detects those and updates the infrastructure accordingly. The GitLab agent for Kubernetes is the foundational layer for GitLab to securely and safely connect to Kubernetes clusters. Besides the push and pull-based approaches to GitOps, the GitLab agent for Kubernetes supports operational container scanning, infrastructure as code scanning capabilities, as well as FIPS-compliant images. Here are some of the benefits that GitOps delivers to teams. As infrastructure configuration is stored as files in Git, it serves as the single source of truth and self-documentation of all of your infrastructure components. The knowledge of your infrastructure is stored in these files, which makes it easy to share across your teams. Moreover, you can confidently duplicate infrastructure components across your different environments, decreasing the risk of introducing errors. This all leads to better collaboration. In addition, all your infrastructure as code files are under version control so that you can easily roll back or roll forward in cases where the infrastructure is misconfigured. You can also tightly couple changes in your application to changes in its underlying infrastructure requirements to prevent unexpected application crashes. This all leads to a lower mean time to repair. GitOps allows infrastructure teams to automate the process of maintaining their infrastructure, which allows them to apply updates faster and detect configuration drifts, leading to productivity gains and faster time to value. Lastly, a GitOps flow includes the process of tracking and managing of all the changes to your infrastructure, including permissions of who can update and deploy configuration updates, access controls, and events logging, which can help organizations meet stringent security and compliance requirements and audits. Everything we have mentioned so far is related to what we call GitOps workflows. However, the GitLab agent for Kubernetes also supports CI/CD workflows that allow you to securely interact with your Kubernetes clusters from a pipeline. This approach allows you to access your clusters without having to expose them to the internet, and it also supports fine-grained permissions to control access to your clusters via impersonation. The combination of GitLab RBAC and your Kubernetes cluster RBAC provides you with a very strong secure mechanism to communicate with and manage the resources in your clusters. Very good. At this point, let's move on to the demo. So we already have an EKS cluster up and running. Here you can see that we're connected to it from a terminal window. And the cluster that we're going to be using is Sysavedra GitOps EKS. Here we check all the pods of the cluster and it looks to be up and running. We're going to start from this group called MG. As you can see, we have a few projects. We're going to drill into GA4K, which stands for GitLab Agent for Kubernetes. We're going to head over to this subdirectory that has the configuration of this agent. That's the ID name of the agent. The login is debug level, and CI access portion of this file is defining that project perms demo will have access to this cluster through its pipelines. So then we connect to the cluster. We have to register the cluster first, the agent, I should say. We register the agent, and then we need to save or copy these commands, the Helm commands, to a local file. We will need this a little later. Here, from the terminal window that is connected to the cluster, we execute the Helm commands. And this effectively installs the in-cluster agent into our EKS. Here you can see it. The name is K8S Agent GitLab. If we refresh this Kubernetes dashboard, you'll see that now the cluster is connected to our agent that is running on the GitLab side. From this window, you can see the details about the agent itself that is connected, and all the timeline activity for it, as well as any security vulnerabilities will be displayed here, and information about the access token that was used to connect to the cluster. Also, we can access the actual configuration file from the agent window, and that's the one that we showed earlier. Very good. So let's go back up to the group MG, and let's go into the project perms demo, which is a demo about permissions. It's a simple pipeline that we have there. All it does, it executes 3 kubectl commands, 2 config ones, and one that is get pods all namespaces. In the demo, you will see how the permissions that we use to connect to the cluster, how it will affect the execution of these kubectl commands. So let's go ahead and run the pipeline. Now we haven't configured any permissions for the agent, so it's using the default agent permissions, which is includes all permissions. So as you can see, the kubectl get pods command was successfully executed, and you can see all the pods that are running on the cluster. So let's get back to the configuration of the agent, GA4K. This is the project where the configuration file lives. And we're going to make some modifications now to the config.yaml file that is configuring the agent K8s-agent. We're going to change and we're going to add this access as CI job lines to the CI access portion of the file. This basically says that we will be running the pipeline and impersonating the CI job itself. Now the CI job itself doesn't have any permissions on the Kubernetes side, so the get pods command should fail. So let's run the pipeline one more time and head into the job. And here, as you can see, there is a user that was created for the job called GitLab CI job and then colon and the number of the job. And since it doesn't have any permissions as a service name, for example, in Kubernetes, it doesn't have the rights to do a get pod. So the get pods command fail for this user. So let's see now the use case where we actually have a user that we are allowing to execute this command. So we're going to create now a service account or user called Jane in our cluster. We're going to create a cluster role, get pods role, and we're going to give it permissions to do a get pods, and then we're going to do a role binding. We're going to bind this role to the user Jane. We also have to give permission to the agent to impersonate other users because we're going to be impersonating Jane. So let's get back to the configuration file of the agent and let's edit it. We'll change the access as line and we'll add impersonate, and then we'll specify the username for Jane. And this effectively what will happen is that the agent will impersonate Jane as it runs the pipeline. So let's go back to Perms demo and run the pipeline one more time. As you can see, Jane has been successfully impersonated and is able to run get pods, all namespaces, as you can see in this last run. So this is how you use the Kubernetes RBAC in combination with the agent to secure your Kubernetes resources. Now in the presentation portion of this lightning talk, we talked about Flux CD. So let's go over of how we've added the integration of Flux into GitLab. To authenticate with the Flux CLI, we must first create a personal access token with the API scope. So we navigate to My Profile, Access Tokens window, and proceed to create one with API scope, and name it pat-4-flux. I have already pre-created one, so let's cancel out of this window. Let's create a new project or repository and call it flux-config. We will need this repository for bootstrapping Flux. Once the Flux CLI is installed, we need to create the environment variable GitLab_token and set it to the personal access token we created earlier. I have already done this, so let's move on to the next step. Now we bootstrap Flux and pass it the location of our GitLab repository flux-config. As Flux initializes, it populates the repository with its configuration manifests to manage itself from it. The Bootstrap will also install Flux on the Kubernetes cluster and create a project deploy token to access the flux-config repository. Checking the pods of the cluster, we now see that there are a few new pods in the flux-system namespace. Heading over to the flux-config repository and drilling into directory clusters/my-cluster/flux-system, we see the Flux components and sync manifests that the Bootstrap created. In this demo, we're going to demonstrate how to have Flux sync the manifests that are being stored and managed by GitLab. Let's create a new repository and name it web-app-manifests. In the new repository, we create a new manifest file for an Nginx deployment. We name the manifest file nginx-deployment.yaml and paste the contents for a Kubernetes manifest for an Nginx deployment. Note that the replica's value is set to 3 in this deployment manifest. We now need to create a project deploy token so that Flux can access the newly created repository. From project web-app-manifests, we head to Settings, Repository, and scroll to the Deploy Token section and proceed to create a deploy token. We give it the name flux-deploy-token and check the Read-repository checkbox. Once we click on Create Deploy Token, the username and password for the newly created deploy token are displayed on the screen. We save those two values for later use. Next step is to create a secret on the cluster using the deploy token username and password. We do this by running the flux create secret command from a terminal window. We can check that the secret was successfully created by running the following kubectl command. From a terminal window, let's keep a watch on the pods of the cluster. Now we need to configure flux-config to sync the web-app-manifest repository by creating two YAML files in the flux-config/clusters/mycluster directory. From a second terminal window, let's clone the flux-config repository. We then head over to the my-cluster directory and proceed to create two YAML files. Notice that my-cluster only has one directory called flux-system at this point. The first one will be a Git source pointing to our GitLab repository web-app-manifests. Notice that this file uses a secret ref to refer back to the project deploy token secret we created earlier. Also, it specifies that every 1 minute the Git repository must be fetched. The second YAML file is a customization resource that tells Flux to sync the manifest from our web-app-manifest repository with Customize. Every 1 minute, the customization runs a server-side apply dry run to detect and correct drift inside the cluster. We commit these two new files to the main branch. On the right side terminal, we can see how Flux detects these two new files and brings the cluster to a new state, which includes 3 pods of Nginx as specified in the observed Nginx deployment manifest and the repository web-app-manifests. We take a peek into the Flux log to see that the updates to the Flux system took place. And finally, we refresh the GitLab window showing the contents of directory clusters/mycluster in the flags-config repository and see the two new YAML files we committed earlier, the Git source and the customization YAML files. GitLab provides you with a way to connect securely and safely to your Kubernetes clusters. By using GitLab, you can streamline your deployment processes to gain better collaboration among stakeholders in your organization, to lower your mean time to repair or preempt unscheduled production outages, to innovate and deliver value to your customers faster, and to improve your compliance and always be audit ready. Lastly, we'd like to invite you to try our 30-day free trial, which includes all of the capabilities that GitLab offers to enterprises. That's it for this session. Thank you so much. Bye.